New here, I'm your host, Stefan Burns, geologist, geophysicist, space weather guy, cosmic bro. I was joking around with myself a couple days ago about how I could just have a video where it's like 5 minutes of endless titles. So, you know, they don't mean much nowadays. Anyone can learn anything. And, well, we're watching Hawaii right now. Kilauea is erupting. And we see it's mostly concentrated in this vent here. But this is the 46th episode. So this is the world's largest hotspot. The Hawaiian volcanic island chain is the world's largest hotspot by most measures. I mean, maybe there's some people out there that would think there's a different one that's bigger. There's a lot of big hotspots on our planet, mantle plumes, etc. But in general, it's recognized that Hawaii is the biggest, and Kilauea is part of this system. We will be discussing some of the science and geology of the Hawaiian hotspot system in general, from a broad perspective in this video. First, we're just going to enjoy a little bit of episode 46. Kilauea first started to have these episodic eruptions back in December of 2024. Now it is May of 2026. Can you believe it? So we now have 46 of these in a row. This is the 46th. It began today, Cinco de Mayo, which also coincides with Taco Tuesday. How about that? What an amazing, amazing coincidence. We love it. Taco Tuesday on Cinco de Mayo. Can't get better than that. I don't know why they shifted the camera down. They're probably in the middle of shifting it once more. They're actively... This is a USGS live feed. So there are 3 different cameras that are positioned around the caldera of Kilauea. And you can look at all the different views. We're looking at 2 of them in this live stream. This is, what is this, the south camera? And then the other one, I believe, is the east camera. Oh, that's not the right direction. But we do see some of this other action from this event and prior overflows. There have been these overflows that have been occurring over the past 36 hours or so. And the lava then cools down into basically like a frothy, porous basalt. And I'm not sure they're switching. They're going to eventually switch it back. But let's go back to the feed that really works nicely for us. So we'll just make sure we get this live. I click this a few times to make it happen. 1 second. There we go. Okay. So this is our live view, kind of head on. And we do get smoke and everything that way, which is why that side view is nice, because we can see it a little better, but they're still adjusting the camera. So, interesting thing about episode 46 is that it began less than 24 hours after a G2 geomagnetic storm, which came as some surprise. Now, we've had some solar activity and space weather and everything over the past 10 days, though the past 5 days or so has been fairly quiet. And when you just have a lot of sunspots on the sun and they're doing things like that, though you may not see these solar storms launch in our coronagraph view, which is a special camera looking at the sun, sometimes these solar storms show very clear signatures launching out. Sometimes they don't. So it takes people by surprise because they're not expecting a storm, and all of a sudden you have some transient, stealthy storm, you could say, embedded into solar wind that then hits us. That's what we had. So we had a G2 geomagnetic storm for 3 hours yesterday. This is a moderate geomagnetic storm. Earth's magnetic field is shaking, undergoing these swings in field strength up and down, stronger, weaker. And then it settled out into a G1 storm for another 6 hours. And what we've been tracking, because I like to get these episodic eruptions from Kilauea up on the screen as much as I can, is often Kilauea pops off right around when there's a geomagnetic storm. Now, interesting thing about that is Hawaii is located fairly close to the equator. So the magnetic field swings aren't that big at Hawaii at the surface, but keep in mind the magnetic field, of course, goes all the way down to the core. And well, this hotspot is a conduit all the way down to the core. So it's not every time, but more often than not, it does happen. And I've been using that as a diagnostic of like, okay, do we have a geostorm coming in? What's Kilauea look like in terms of the tilt data? Maybe it's about to go off. It's happened where it's gone off early. People weren't expecting it, but we had a geostorm like right then. So it's not every time, but we did have that, and now we're seeing Kilauea pop off for the 46th time in this eruptive sequence. So that's quite cool. Let's see what maybe the other camera is doing again. Let's see if it's updated. That's not the live. There we go. Okay. They're really punched in there. Or there we go. Not punched in, zoomed out, I mean. I like this view though. I can punch in myself using my live stream software. So let's do that. Let's take this nice view that we have and put it on the left side of the screen. Oh. They may adjust it further, but we will see. But this looks pretty awesome. So these lava fountains, I think, are quite tall right now. And let me actually zoom this out just a little bit more. It's a little too zoomed in. And we are going to get this one to pop off. So what's been happening recently is we've had one vent dominate until sometime into the eruption, and then we get the second vent to start waking up and really go. And this just started in the past hour. So I think this vent probably within an hour will be pumping. And we should likely have 2 simultaneous lava fountains, which would be really cool to see. But this needs to get zoomed out even further, right about there. Yeah, looks good. And let's see what the latest update is. USGS posts to their website, Kilauea updates. And right now it says at 9, okay, so 11 minutes ago, north vent fountains are 500 feet tall or 150 meters. Intermittent bursts of spatter are visible from the south vent. The eruptive plume is 15,000 feet above sea level. So if we go to our other view, you know, kind of extends upwards. But in terms of the lava fountains, right now they're about 500 feet. I think they've grown a little bit in the past 10, 12 minutes. So probably a little closer actually to maybe even like 550 or 600 feet now. But in the past, they have been significantly taller than that. So it'll be interesting to see how tall these ones get. Oh, yeah. And the other message here that was posted a minute after that one is winds are light and variable from the southeast this morning. Tephra may be distributed throughout the summit region and northwest of Halema-Uma'u. Sparse lapilli-sized tephra is falling at Uekahuna and near Namakanipaio. I hope I pronounced this right. So any native Hawaiians or people watching that live in Hawaii that know the pronunciations, the words, the names, everything. I love Hawaii. I've been there many times, but you know, I'm still learning. So thank you for your understanding. I do my best. I really love Hawaiian culture. It is, I think, of course, there's been many amazing cultures that have formed throughout our time here on our planet, but there are few that are as connected to Mother Nature as Hawaiian culture. And not just Mother Nature, but also the cosmos too. They have an incredible astronomical component to their culture as well. Completely different constellations and star maps and everything than Western cultures, which use the zodiac and everything. It's really fascinating stuff. If you go to the Big Island, there's an astronomical observatory museum in Hilo, and they talk about all that there. Really cool stuff. So we have Hawaii popping off, episode 46. And let's learn a little bit about Hawaii. But first, I just want to show you this solar wind structure and geomagnetic storm that we have just gone out of. So we can look at that right here. And this is our real-time solar wind. This is a 3-day view that we're looking at. We see our solar wind did start to increase and strengthen. And then this red line there is signifying the polarity of the solar wind. And so when it goes negative, Earth has a positive polarity magnetic field, you could say. The two connect together very nicely. So we see that all of a sudden, boom, it dropped really quite far down to about 12, negative 12, negative 10, negative 12 nanotesla, right in that zone. Yeah, it looks like negative 10. And the solar wind was 2 times stronger than normal. Black line represents the total field strength. Normal is 5. So if you're at 10 or 11, you're about 2 times stronger than normal. That then quickly brought about a G2 geomagnetic storm. So we see that here with our KP index, a measure of the volatility in Earth's magnetic field, 3-hour measures, 1, 2, 3. This is a G2 level at a 6.33 value. So it's actually G2 plus. And then we had 2 hours of G1 storming. G1 is moderate, G1 is minor, G2 is moderate, G3 is strong, G4 is severe, G5 is extreme. So this is just a moderate to then minor geomagnetic storm. We see that as the polarity on the magnetic field went into the positive territory, our magnetic field cooled off, but this was just, these are 3-hour blocks, right? So we have 3, and then we have 9, and we have, 6 and then 8. So that right there is 24 hours. It was just within the past 24 hours that we had this occur. And let me show you where Hawaii is on the map for some of you that may not know. Pull that up. Here we have Hawaii on Google Earth. And so we see that it's right smack dab basically in the middle of the Pacific Plate. It's a little bit in the northern part of the Pacific Plate because the Pacific Plate goes all the way down here. But in general, it's pretty much right in the middle of the Pacific Plate, which is the largest plate on our planet, plate tectonics. It's the largest plate. It's interesting that you have the world's largest hotspot basically in the middle of the world's largest plate. Personally, I don't think it's coincidence. I think there's a lot more, I don't want to call it design, but there's a lot more reasoning for the structure of the Earth than it just being random, okay? It's like everything has a reason and a purpose. So we see the world's largest hotspot right here, actively creating islands. We have the big island, oh, there we go. We have the big island right here. This is where we have Kilauea. We can specifically zone in on Kilauea right here. There it is. Boom shakalaka. This is where this eruption is occurring. It's connected into this whole system because we have bigger volcanoes on the big island. You have Mauna Loa. And then if you go to the north, you have Mauna Kea. This is where all the observatories are. All these really advanced astronomical observatories that are making incredible discoveries of our cosmos are located on Mauna Kea. It's much less active than Mauna Loa. Mauna Loa, as you can see, has tons of lava flows that have occurred just in the past 5,000 years. I think the overall coverage for the slopes of Mauna Loa in the past 5,000 years is like 80%. So you even see flows coming down, for example, all the way to the ocean. You see them coming down here, south part of the Big Island. There were some really destructive lava flows in 2018. And even places here like near Captain Cook and Kilauea Kona, you have these older lava flows that have come down. But again, 80% renewed in the past 5,000 years. I believe that's the stat. If it's not exactly that, it's pretty darn close to it. But Kilauea is the one that's really been active, and it's active in a way that is fairly safe. Like a few eruptions back, a few episodes back, it did put out a lot of tephra, and there was pumice raining down and Pele's hair and all this crazy stuff. But in general, during an episode like today, the park I'm sure is open. There are people right now at the Overlook watching this. I mean, when I was there in August last year, it was similar to what we're seeing right now. If we go back to that, here we have it. Make sure that this, yeah, okay. So people right now are at the park, I'm sure, watching this. If you are there, it'd be great to see you comment. But what's cool about Hawaii, if we go back to our Google Earth, you zoom out, the Big Island is the only place in the United States that's actively growing. And, well, it shouldn't be part of the United States. They just, the United States basically just completely took it over. We didn't even vote on it or anything. It's like one of the biggest crimes. But anyways, it just pisses me off. This overreach. Anyways, here's Maui. Here we have Molokai. We have some of these other islands. We have Lanai. Here's Oahu. This is where most people live in Hawaii. This is the capital area, Honolulu. I'm not sure. I think Honolulu is the actual capital. Regardless, it's like 1 million plus people on Oahu. Here you have Kauai. And then you have the island that's only open to Hawaiian local natives. It's like the Forbidden Island. And then after that, you have all these submerged islands now where they're just atolls and they've sunk beneath the waves. You have this active island creation with the hotspot, but as the plate moves over the hotspot location, these of course move off of it, and there's this inexorable draw downward subsidence. So eventually they sink beneath the waves, and we're just left with little remnant leftovers. So this was once a big island. As you can see, not anymore. This is a big island right here, and now we have just this little Necker Island, just a little bit of like probably the uppermost rim of the volcano sticking up above the surface, which is pretty cool. But if you go zoom out, you see that there is this alignment here, and this represents millions and millions of years of plate movement. And then you see this bend here, which I think occurred around 45 million years ago, if I'm not mistaken. And so you see that there was this transition with the plate tectonics around the time of this bend, and then you see this chain even going further north. So Hawaii is really quite an amazing place geologically, and it's one of the main locations on our planet that's helping us to reveal the secrets of Earth's interior because of the magma composition. The chemical composition of the magma and more is helping us to really understand what's been happening on our planet. For example, this lava here right now is superheated. You have something known as the Curie point. That's C-U-R-I-E, Curie point. And when you have a rock that is melted beyond its Curie point, actually it doesn't even need to be melted, but it's heated up beyond its Curie point, it loses its magnetization. Because in igneous rock, which is what we have forming here, you have a lot of magnetite, titanomagnetite. You have these magnetic minerals that are embedded within this whole assemblage, you call it. And when they are cool, below the Curie point, they have a weak magnetization to them, and they'll align to Earth's magnetic field. And so the remnant magnetization of Hawaiian lavas are an excellent geologic record of Earth's magnetic field strength in that location, and also the inclination and declination across time. So you have Hawaii acting as a log, all these different lava flows, you date them and radiometrically, and then they perform the analysis on the remnant magnetization, and this allows us to construct an idea of what Earth's magnetic field looked like going back in time. Now, it's for that location. The magnetic field varies across the globe, but it's a super important data point stretching across thousands and thousands of years, so many data points. Hawaii has that going for it. You can measure the chemical isotope ratios and more of Hawaiian lavas to help understand what's happening deeper in the planet, because this hotspot plume, the mantle, the mantle plume goes down to the core mantle boundary. So it's deeply anchored into the Earth. And for example, you have a very unique helium ratio that's observed at Hawaii. So this is helium-3 to helium-4. So you have a helium with 1 neutron, you have helium with 2 neutrons, right? It's 2 protons for a helium. Hydrogen is just 1 proton. If you have deuterium, then it's a proton and a neutron. This is like heavy hydrogen. But for helium, you usually have 2 neutrons. But you can also have helium with just a single neutron. That'd be helium-3. So these helium-3, helium-4 ratios are super, super interesting because they give us a glimpse into the processes occurring in the deepest part of our planet. And they are connected to nuclear processes. Nuclear fission, nuclear fusion. When you have all these particles smashing into each other, or you have them radioactively being flung off, let's say uranium, plutonium, whatever, right? You can get helium-3 to be made or helium-4. So the current idea for the tremendous amount of helium that we observe in the deep Earth, specifically around the core mantle boundary, this is what mainstream geologists think, is that it somehow accreted. During the accretionary process, there was this deep helium reservoir that was created that's effectively stayed inert, but these hotspots are a little bit of a sampling of that. And we do know that, well, we have really good ideas that during the accretion of the Earth, these meteorites can contain these sort of volatiles because they formed out of the protostellar disk, where you have a lot of light elements, and helium, remember, is a noble gas, so it doesn't react that easily. But it is a light element. It really resists the force of gravity because it is so light. It doesn't mean gravity has no influence over it, but you light up a helium balloon and that thing flies straight up. Go back to the Zeppelins of Germany, right? They're using hydrogen even more. Has an even easier ability to float away in the atmosphere because it's so light. But of course, hydrogen is flammable, so that didn't work out for them. But helium is very light, floats away. It wants to go up to areas where the density is quite a bit lower. It just has more energy in it, effectively. So how is all this helium in the deep Earth? That's really a question that many people are still pondering. Some people, they put the stamp of this is exactly what it is. We don't know. These meteorites that formed little planetesimals, which then all impacted together to form the Earth during its evolutionary history, would contain some of these volatiles. But during the impact of these meteorites and planetesimals to the growing Earth embryo, you'd expect these volatiles to get released and a lot of them to off-gas. We also know that when there is a heating of material, just like we're seeing here, right? Like hot molten material, a chemical differentiation occurs and you'll have heavy elements sink and light elements rise. And so if you follow out this logic, it doesn't make too much sense for there to be such vast amounts of helium in the deep Earth. And it's not just helium, it's helium with very specific He3, He4 ratios. So one of the ideas is that in fact and I'm not saying that this is the case 100%, it just really, I think there's really something to it and shouldn't just be ignored. One of the ideas is that there is a deep Earth reactor that exists and that there is nuclear fission occurring within the Earth. Now, the geologic evidence suggests that most radioactive isotopes actually accumulate in the crust due to them being carried upwards by some of these chemical differentiation and convection processes. But there are radioactive isotopes in the core itself, and if you have a sufficient concentration of them, you can have a natural georeactor. And we have geologic evidence of nuclear fission georeactors occurring that specifically from France, it's like they're like 1 billion or 2 billion years old, and we see the remnant of that natural georeactor. So this idea is that there is a georeactor or many georeactors of different sizes and scales and intensities, whatever, power, in the deep earth that could be generating this, this helium and creating these helium-3, helium-4 isotope ratios, which are quite unique and primordial. And it doesn't require some explanation of somehow this reservoir was just accreted to the deep earth. And we wouldn't know. That doesn't really make sense. But there being these natural georeactors do. And that could then also explain connections to the geomagnetic field, Earth's magnetic field. Because again, this goes straight down. So Hawaii is this glimpse into the deep earth. Not only the magnetic field, the geodynamo, but also perhaps even these georeactors that exist that turn on, turn off, and more. So let's give that a look. We have two different graphics here I'm going to show you. Here is one showing an illustration of this conduit underneath Kilauea. We see Kilauea right there. There's a caldera. You know, it's changed, of course, but here we see Kilauea, and we see this plumbing going all the way down. So here we see the oceanic crust, the depth here being 10 to 15 kilometers down. This is the main volcanic shield, the island of Hawaii. Has deep roots. Here's the oceanic crust that's sitting on top of. Here's the upper mantle. So this goes all the way down into the upper mantle. And below that, this illustration is just showing how it expands out into the upper mantle. And this is the primary conduit coming up for Kilauea. But there's more than just that. There are other conduits as well. We can see that here with this graphic. So here we see Kilauea, and in this one they show this summit magma reservoir actually having quite a lateral extent. And then there's these rift zones, and we see magma sometimes come up in these rifts. There's also, if you've ever been to the Big Island, there are extensive lava tubes all across the island. You can explore them, and you can explore them around Kilauea. They go right up to Kilauea. I mean, not all of them have been mapped or anything. You know, there's active lava tubes right now that are pushing magma to these different locations. But it's really quite incredible, these lava tubes. And you can find them all across the island. Talk to any locals, and they'll tell you that. And you can find them on this all around the summit of Mauna Loa. You know, the sides and everything. There's lava tubes. I'm not the ultimate expert, but I've been in some in the volcanoes park, or Hawaii. What's it called again? Hawaiian Acres. In Hawaiian Acres. There's tons of lava tubes there, and you can book tours and everything. But here in this diagram, we see this larger magma reservoir connected to the hotspot and the mantle plume that's connecting both of these together. So we do have a pretty good understanding of what exists with the Big Island of Hawaii, but we're always learning more. Something that we've learned recently is that there's extensive freshwater reservoirs around the Big Island. And not just on the Big Island, but actually extending out underneath the ocean, but in the crust. I don't fully know the story, but they have found these really extensive freshwater reservoirs all across the Big Island, which is quite remarkable. So there's some very unique things happening here geologically. That is the point that I'm getting to. And let's actually look also at the earthquake activity that we have for Hawaii, the Big Island, because it can get big earthquakes. So let's check this out. And I just want to make sure this is now live. Here we are. Okay. So I'm going to pull up the earthquake activity for the Big Island, going back to, I guess, 1900. I'm not sure how many old earthquakes will show up in the USGS record, but we'll do minimum magnitude 6. And this is always interesting. A lot of people don't realize how active Hawaii is in terms of these big earthquakes. It can get magnitude 7 earthquakes. It's really quite remarkable. So this should do it. Okay. Okay, so here we have our earthquake history for the Hawaiian Islands, magnitude 6 or greater, going back to year 1900, January 1st. We see one there, magnitude 6.6, north of Maui in 1938, quite a long time ago. But in general, you see that they are clustered around where the hotspot right now is located. So, I mean, you can also have earthquakes because you get some fault and slip and everything, but in general, these are volcanic-based earthquakes. And one sense of scale that you can develop for how big a volcano truly is by looking at the maximum earthquakes that it can generate. Because volcanoes can create earthquakes through the movement of magma and other processes. So here we see a magnitude 7.7. 1975. That's a big earthquake. I think that might actually be the largest. Yeah, magnitude 7.7, 1975, just to the south-southwest of Leilani Estates, right off the coast. I think it's just barely off the coast right there. Clearly connected to all this plumbing and more. But you also see a 6.9 there, same location. That's 2018. 6.7 here, slopes of Mauna Loa, and just in general, 6.7 here to the north, and well, more to the northwest. But you see that Hawaii can get these big magnitude 6 earthquakes, and also big, even magnitude 7 like this one. Though the only magnitude 7 in this record is from 1975. And there's a lot more of these magnitude 6s than there are, like these low magnitude 6s than there are these high magnitude 6s. But a very dynamic history to Hawaii. We even see some magnitude 6s up here off the coast. So it's a very active spot geologically. And one thing that I can also share is that when I was there, I talked to some people, of course, that lived there. I did my best to really learn a lot. And there were people that are living in Pahoa. And they're like, yeah, we're feeling these microtremors all the time. That was August of 2025. But let me show you Pahoa on the map. It's just to the northeast of Kilauea. But here's Pahoa right here. And that's where a lot of these lava tubes are. And of course, here's Kilauea again, right? There's Kilauea right there. And during like 2 or 3 episodes back, there was tephra falling all across this area here. Volcanoes Village, the golf course, huge swaths of this area. We had pumice raining down and more. But if you talk to the locals, they're like, yeah, we're feeling these minor earthquakes, microtremors and more all the time around this area. Hawaiian Acres, Pahoa, Leilani Estates, and more. Really quite incredible. So this is a very, very active place. It's very active. It's not a place to take for granted. It's very dynamic. You get a lot of fog, you get big earthquakes, you get volcanic eruptions, you get pumice raining down. And this is just from Kilauea. What if you have a big one pop off here, Mauna Loa, right? Now you're really talking. So that's all possible. Let's go to our other feed to see what it looks like. Looking pretty big. And let's get an update now too on the height of this. I'm sure the USGS has updated their height for this. trying to get this live footage. There we go. That one, for some reason, I have to click like 10 times. So let's see what they are saying as it relates to Kilauea right now. Okay, the latest update from a minute ago is that the National Weather Service reports the eruptive plume is about 20,000 feet or 6,000 meters above sea level. Sparse tephra fall between mile markers 31 and 32 on Highway 11. Okay, so we're getting tephra coming down from this. They have not updated the height on this, but I think it's about the same height. Maybe maximum 700 feet. This is not a 1,500 foot tall lava fountain right now. It's in the 500 to 700 foot range. Maybe a little bit more, but I think it's probably max 700 feet right now. And another interesting thing to point out is what's been happening with the eruptive cycles recently. So let me show you that using our tilt data. So we'll come back to this. Here we have our tilt data for Hawaii, and this is for the past 2 days, past week, past month, and we can see that we were inflating and now we're starting to go down. We're in episode 46. Even though the lava fountains aren't 1,500 feet tall, this is clearly episode 46, occurring just again less than 24 hours after a G2 geomagnetic storm. We see here very clearly that we had this lengthening of these episodic eruptions. The inflation in between was lengthening out, and they were also big eruptions. Look how much it was discharging there, huge discharge. The past two specifically, 45 and 44, have been fairly short and have not discharged as much as the prior ones. This one even less. Look at this trend line there. This one even less. And it reached just about the same inflation value there before it started to discharge again. And if we look at our full time series here, we can see that this is going all the way back to December of 2024. We have all these eruptive cycles. The beginning ones aren't too important for what I'm going to talk about right now. But you see that they were getting bigger and bigger and bigger. We have some really big ones. I mean, there specifically, things definitely changed. There was a magnitude 4.4 earthquake that struck within 10 minutes of that episode ending. Really quite incredible. And then you started to notice, before it was very regular, this inflation and then the eruption, inflation, eruption. It was very regular. I mean, we had like one oddball there. But for the most part, very regular. Then we started to see some variability where there would be these overflow events where you get some lava to overflow, the tilt would go down, the magma chamber's breathing, right? Like Kilauea is actually breathing effectively, like this longer earth pulse exists at Hawaii. And that started to influence the lengthening of these cycles, and now we seem to be undergoing this larger inflationary trend again because we had higher inflation back here. Then we really dropped down. So it'll be interesting to see if this wraps up soon. Like these eruptive episodes eventually will end. But we could, for example, start to not have these eruptive episodes where we may expect them based off of prior episodes. And maybe the inflation starts to get back up to some of these levels like around here. And then we get big eruptive episodes again, where it's like 8, 10, 12 hours long, and the plumes are 1,000 feet, 1,500 feet, 1,800 feet tall. But this is where we are right now. There's been this shortening of this cycle. Look how quickly this one occurred. It's very reminiscent to back here, where we were getting them like every 10 days, every week, every 10 days, very, very fast. So this is where we are right now in this cycle for Kilauea. And this eruptive episode has just begun. So there's probably at least another 6 hours here until this wraps up. And if I just look at the tilt data myself, let's get a look at that. Yeah, I mean, we're just starting. So we could see a surge. We could see this go higher. But we probably have at least another 6 hours of lava fountaining before this wraps up, which is pretty cool. And here's our latest from our south camera, V3. And the other vent is actually it's completely quiet, which is interesting. So if it stays quiet and it doesn't have any fountaining through it, then this could extend out this fountaining episode even longer. Because if you have double the discharge rate, well, it's going to go twice as fast. So right now we only have, oh, well, there's a little splatter right there. But we only have the north vent right now that's going. I believe that's the north vent. And it's the south vent. Yeah, the south vent is just splattering right now. I think that's everything I wanted to present on Hawaii. There's only one other thing I could look at, which we will do that. One other thing to consider is putting Hawaii in context of other volcanoes. So we can do that by looking at our Morova data. Here we have our Morova data, and this shows us the radiative log power for Kilauea or other volcanoes based off satellite observations. So you see up there it says middle infrared observations of volcanic activity. Right now we're not getting any measurements from Morova. It's not super immediately up to date, but cloud cover and other things can also influence these measurements. But we see these eruptive episodes very clearly because the radiative power goes right up to the extreme level. Here we see episode 45 straight to extreme. So it's not often a volcano will hit extreme on the radiative power scale. Usually it's high, maybe it's very high. As you can see, Kilauea is regularly hitting extreme or very high levels. So this is significant. How many volcanoes are you seeing on the planet have these 1,500-foot lava fountains twice a month or every 2 weeks? Not often. So we've kind of normalized it a little bit because we have these live streams and in general no one's getting hurt or anything. But it doesn't mean that this isn't a big deal, that it's not powerful, that we're not seeing geologic changes unfold in real time. Here we see the non-logarithmic scale. Right? We see that these extreme values are quite a bit more extreme than others, right? Because this is a linear scale here. This one's logarithmic. So it really puts it in the order of magnitude jumps, 10x jumps. So Kilauea is a significant volcano. It's been releasing a lot of energy for the Earth since 2024, December of 2024, all through 2025, thus far all through 2026. And we don't know when this is going to end. It could very well continue on for another 2 years like this. We don't know. It all depends, again, on that plumbing underneath Kilauea and, in general, the hotspot mantle plume for the Hawaiian volcanic chain. And I lean more towards the fact that everything's interconnected. If you read any of the new research papers that are coming out in geology, that's where people are finally starting to go as well. Like mainstream scientists are starting to realize that things are more interconnected. There's research papers coming out that are showing that the San Andreas and the Cascadia subduction zone are linked together, and that they often rupture at the same time with big earthquakes. There's a research paper I just read yesterday about in the Aegean Sea with Santorini. You had the big volcano there. It's had huge explosive eruptions like the Minoan eruption, 1600 BC. Very destructive. You have Colombo underwater volcano nearby. They're showing that those two volcanoes are connected together, all part of the same volcanic field. Whereas before people thought they were a little bit more separate. Well, no, the evolution of Santorini has coincided with the evolution of Colombo volcano in the Aegean Sea, Greece. Mediterranean. So things are way more interconnected than I think most people realize. We are still actively discovering this. We know this much about the Earth, and this is everything that's out there. So this is a fantastic location to watch, to better understand these interconnected systems. Again, I don't think the correlation with the geomagnetic storms and Kilauea popping off is just coincidence. It's not every single time. Again, it's a correlation. It's not perfect, but we do see that connection. And as I described, the magnetic field, 99% of it or more is absorbed into the mantle. It's not like the magnetic field for Earth is generated just below the surface and then streams out. You have massive, massive, super strong magnetic fields in the core where it's being generated, and 99% of that force at a minimum, it could be 99.5%, it could be 99.9%, is absorbed into the Earth, right? The magnetic field is a force field. It's a force flows along these fields. It guides the movement of the magnetic force, which is one of the fundamental forces of the reality in the universe and nature. You have electromagnetism, electric field, magnetic field. The two come together. So when we're talking magnetic fields, you're also talking electric fields, very powerful electric fields to generate a magnetic field that after being attenuated 99% minimum still is picked up at the surface of the Earth all around on average at a field strength of about 45,000 nanotesla. It's crazy. Now a little fridge magnet may be stronger than Earth's magnetic field in the palm of your hand, but that fridge magnet doesn't have the strength of 45,000 nanotesla on the other side of the globe. That's the difference. This is a giant magnet that we live on, and most of that energy exists and is absorbed in the mantle of our planet. And this conduit, this hotspot, cuts directly through the entire mantle, which is the majority volume of the Earth, and connects into the core mantle boundary. That is the best evidence that we have, is that it goes down to the core mantle boundary. And the strongest evidence for that are these helium ratios, because we see these very, they're not unusual, but we see a big differentiation to He3, He4 ratios. So really incredible stuff. So it's useful to watch this live, I think, to track this, to get into resonance with Kilauea, Pele, the lava fire goddess, right? And therefore these secrets can kind of divulge themselves over time to you. And that is why I do my best to capture every single eruptive episode at Kilauea now for dozens and dozens. I've been doing this for a while. So thank you all for being here, for joining in on the live stream. We're going to keep it going for quite some time, but I'm going to finish my component now with a singing bowl. We're just going to play the singing bowl for a little bit, which is always nice. Frequency, vibration, sound, all this is really good. So I'm just going to enjoy the singing bowl for a little bit before I turn myself off, but I'll keep the live stream going so you guys can keep watching Mother Earth display herself in all her glory. And well, I will turn myself off for this so you can see the volcano better, but you'll have the sound. So let me reformat this. Well, thank you all, everyone, for joining me today. Live stream will keep going, but this portion is done. So if you enjoyed this, my presentation, the sound bowls, everything, then please make sure you hit that thumbs up button. It does help. Subscribe to stay up to date with what is happening with the Earth energetically, our sun, the cosmos, with yourself, and more. I release videos almost daily here on my main channel at Stefan Burns or on my Clips channel at Stefan Burns Clips. I will be back with more, actually maybe back with a live stream fairly soon after this one. There is a SpaceX launch from California today. I may try to catch the space jellyfish, especially if they delay it like 20 minutes. We're gonna get a really amazing space jellyfish. So be on the lookout for that live stream. And also, we have an in-person event coming up in California. So I'll be releasing those tickets very soon. So be on the lookout for more information on that as well. Super excited to see so many of you in person here in San Diego. So sending you lots of love and light. Enjoy a good amount more of episode 46 for Kilauea. It's probably going to go on for another 5 or 6 hours. The flow rate's fairly slow right now, maybe even longer. So I can't guarantee the live stream will be up for all that, but the links to the official USGS live stream are in the video description, and there's other people that restream this as well. So all these options are available to you. So thank you so much. Have a great day. Happy Cinco de Mayo, Taco Tuesday combination. Get out there, have some fun. I'll see you all very soon.